Have you ever wondered what makes something feel, expensive? It's not just about the brand name slapped on it. Turns out it's a whole lot of science. Today, we're going to dive into the hidden engineering that makes the products we love not just work great, but look and feel absolutely incredible. All right, let's get started. I mean, you know the feeling, right? You pick up a high-end laptop or a really nice watch, maybe even just a solid, well-made tool. There's just a certain heft to it, a smoothness, a feeling of pure quality. It's something you can literally feel in your hands, and it goes way beyond just the logo. So the big question is, where does that feeling actually come from?
Well, it turns out that premium feel is no accident. Not at all. The secret is actually engineered, and it's hidden right there on the surface of the material. See, a product's finish isn't just skin deep. It's a totally critical part of its performance, its durability, and yeah, a massive part of how we perceive its value.
So in this explainer, we're going to look at how modern manufacturing goes way beyond just cutting a perfect shape. We're diving deep into how engineers can take a simple metal surface and transform it into this high-performance shield that, oh, by the way, also happens to look and feel amazing. Okay, but before we get to the cool solutions, we've got to understand the problem. So let's take a look at what a metal part is really like right after it comes off a CNC machine. Computer numerical control, where computers automate all that super precise cutting. We need to see why that's just the beginning of the story, not the end. So, you'd think a part that's machined down to microscopic tolerances would be pretty much done, right? I mean, it's perfectly shaped, it's strong, but if you zoom way, way in, that raw surface is actually a bit of a battlefield. It's totally exposed and vulnerable to, well, everything, from the moisture just hanging in the air to the simple friction of using it every day. And when you put them side by side, the difference is, wow, it's night and day. A raw surface, it's gonna corrode, it's gonna wear down, and it's full of these tiny little pores and cracks that can turn into huge points of failure later on. But an engineered surface, it flips the script. It takes every single one of those weaknesses and turns it into a strength. Suddenly you've got protection, you've got durability for the long haul, and you get that beautiful uniform gloss we all associate with high quality. So the question is, how do you get from that vulnerable, raw state to that perfected, engineered one? Well, this is where the real science kicks in. We're talking about something called advanced surface engineering, a whole field dedicated to transforming and protecting materials at the most basic, fundamental level. And one of the absolute star players here is a process called plasma electrolytic oxidation, or PEO for short. It's a pretty wild electrochemical process. What that means is it uses electricity and a special liquid bath to basically grow a super hard, dense, ceramic-like layer right out of the metal itself. Seriously, it's like giving the metal its own permanent suit of high-tech armor that also happens to be a major fashion statement. Now, this whole journey to a perfect surface usually breaks down into three main steps. First up, you've got preparation. The part has to be cleaned and prepped meticulously. Then comes the coating application itself, like that PEO process we just talked about. And finally, and this part is absolutely crucial, it goes through post-treatment and finishing. That's what really seals in the performance and dials in that perfect look. Okay, so the theory is cool and all, but let's see how this stuff actually works in the real world. We're going to look at a few recent studies that show exactly how engineers are taking on these challenges with all sorts of different materials. First up, let's talk about magnesium. This stuff is incredibly lightweight, which is awesome for things like aerospace and car parts. But it has a major weakness. It's notoriously bad when it comes to corrosion. So how do you protect it and give it that premium feel? Well, a study by Hassan and Khan gives us a really clever answer. What they figured out is that after you apply that PEO coating, you can actually go back and machine the very top layer of the coating itself. And that's the genius of it. This extra step smooths out any tiny pores or micro cracks that might be left over. The result? A way denser, more uniform surface that has dramatically better resistance to corrosion. Super smart. All right, next up, aluminum. And not just any aluminum. We're talking about AA7075. That's a super high-strength alloy you'll find in everything from aircraft frames to fancy bicycle components. With this stuff, the challenge is a double whammy. You need to protect it from wear and get that perfect, slick finish. So two researchers, Arslan and Demirtas, they focused on tweaking the PEO process itself.
By getting really precise and adjusting things like the electrical current and frequency, they created a coating that didn't just boost wear resistance, it also seriously improved the visual texture. It's just a perfect example of how performance and aesthetics are really just two sides of the same coin. And for our last case study, let's talk steel, specifically the kind of high-strength steel they use for really critical parts, like bolts. For these components, the number one enemy, hands down, is corrosion. Because if a bolt like that fails, you're looking at catastrophic failure. So a study by Sun and his team dug into cadmium coatings. And what they found was that the steps you take after the coating is already on there are unbelievably important. It turns out, by using just the right post-treatment solutions, they could slash the number of surface defects, little pits and cracks. And the end result is a much more uniform, and because of that, a much more protective surface. Okay, so we've seen the science, which is awesome, but why does all this super intensive engineering really matter in the big picture? Let's zoom out a bit and look at the market to see how all this stuff builds real, tangible value. Check this out. A 2021 study from Wu and his team really shows just how far we've come. They compared old-school hard chrome plating to a modern method called HVOF thermal spray, which basically uses a super fast jet of gas to blast the coating on. And the difference in performance? It's not small. We're talking a massive, massive leap in both wear and corrosion resistance. This is the kind of measurable improvement that can literally change entire industries. And of course, a huge leap in performance like that translates directly into real benefits for everyone. For you and me, the consumers, it just means we get better, more reliable products that last a whole lot longer. For businesses, it means happier customers and a much stronger competitive edge. It really changes the entire game of product development, forcing designers and engineers to work together right from the very beginning to blend function and feel perfectly. So let's tie this all together. What we've seen is that the look and the feel of a product, they aren't just superficial things. They're not just for show. They are the direct, measurable result of some very serious engineering. And this quote really just nails it, doesn't it? It captures the core idea from all this research. At the end of the day, you simply cannot pull apart the beauty of a modern product from the incredible science that creates its surface. The two are just completely woven together. So yeah, the next time you pick up a gadget that just feels right in your hands, it has that perfect gloss, that really satisfying texture, that solid sense of durability, just remember, that wasn't an accident. That feeling was designed. It was tested. It was meticulously engineered, one tiny microscopic layer at a time. And that leaves us with a pretty fascinating question to think about, doesn't it? As our ability to engineer these surfaces gets more and more advanced, blurring that line between how something looks and how it performs, what kind of incredible new products and possibilities is that going to unlock? I mean, what will we build next when beauty and strength are truly one and the same?